Okay, so 5-3, day 2. Want to look at this problem here and say, is it binary or not? You put all the names of students in your class in a hat, mix them up, draw 4 names without looking, and y is the number of students whose last name have more than 6 letters. So it is binary. Either they have more than 6 letters or not. Okay. Independent though. Okay, and the same probability. Okay, there is a set number, right? Where n equals 4. But these two right here, if we pick a student, pick the first student, okay, then the probability of the second student changes. Okay, so if the probability of the second student changes, therefore it is not binomial. Okay, the next one, you roll 2 die, six-sided die. Probability of rolling doubles is 1 out of 6. Suppose that you roll it 4 times. W is the number of rolls of doubles he gets. So it's binary, so it's either doubles or not, or it's not doubles. So that's good. Independent. One roll is independent of the other roll, right? Once I roll it, it doesn't impact the other rolls. The set number of trials, okay, we're rolling it 4 times. And the success rate, the probability, is each time 1 out of 6. So it is a binomial with n equal 4 and p is equal to 1 over 6. Okay. Third one, we're looking at this problem here, and what's the probability he rolls doubles twice? So probability that he rolls doubles, he's going to roll 4 times. What's the probability he gets doubles twice? Okay, so we would have, we want to roll doubles twice, so 1 6 2 times, and then he doesn't roll doubles 5 6 of the time. We want that to happen the other 2 times. And we're rolling it 4 times. How many different ways can I get those? So I could roll doubles first, or first and second, or first and third, or first and right. Okay, there's different ways I could do that. So 4 choose 2 is 6. So 6 times 1 6 squared times 5 6 squared. So there is about almost a 12% chance that when I roll doubles, I'm going to roll it 4 times, I'm going to get 2 doubles. Okay. The next one, number 10, is to make a histogram out of this. Okay, so now we've learned how that we can use Desmos for this, right? So in Desmos, you're going to go and I'm going to do it here. I'm not going to necessarily share my screen with you because I'm not sure how to do that. I don't think I can. But if you go under functions and under distribution, you're going to type in binomial, IAL, binomial distribution. Okay, and then under binomial distribution, it asks for the number of trials, which was 4. And the success, which is 1/6. So 4 comma and then 1/6. Okay, and it gives you you can hit the little thing to look at the zoom fit. So the probability of we can get 0 doubles, or 1 double, or 2 double, or 3 double, or 4 doubles. Okay, we already figured up the probability of 2 doubles to be almost 12%, and if you click at 2, you get 0.0115, so basically if we round it to 12%. At 3, it's 0.02. At 4, it's 0.0008, so almost 0 there. At 1, you have a almost 39% chance of it happening, and getting 0 doubles would happen 48% of the time. Okay, so if we make a histogram out of this, Okay, so rolling 0 doubles 48% of the time. Rolling 1 double 39% of the time. 2 doubles 12% of the time. 3 doubles 2% of the time, and 4 doubles is almost not going to happen. So this is skewed to the right. Okay, so Desmos makes that a lot easier than what we did yesterday. All right, number 5. Pedro drives the same route to work Monday through Friday. His route includes 1 traffic light, and according to the traffic department, there's a 55% chance that it's going to be red. So on a randomly selected day. So we're going to choose 10 days that he goes to work. Y is the number of times he gets stopped by a stoplight. Okay. Why is it binomial? It's either red or it's not red. So good. Independent from one day to the next. We're good there. There's a set number of trials. We're going for 10 days. And the probability each time of getting a red is 55%. So it is binomial with n equal 10 and p equal 0.55. Okay. Part B, and find the probability of y equals 8. Okay. So we want to get a red light 8 times out of the 10. So it'd be 45% of the time we don't get a red light. And how many different ways can you arrange these? 10 choose 8. Okay, so 10 choose 8. There's 45 different ways you can do that. Okay, there's 0.076. Okay, there's a 7.6% chance that 8 of the 12 days, 10 days, will have red lights. Okay, so 8 of the 10 days, 7.6% chance he'll have red lights. Okay, and the 6th problem is this one. We want to make a histogram of this. So once again, go to Desmos, okay, and binomial you know what? I'll show this one on the computer. So I'm going to stop the recording here and show it on the computer. Tag it on the back here. So we're looking at that problem with the red lights. So we said it was binomial. So I can come down here. Hide the tools here. See. Okay, so I can come down here, show this. Functions, go to distribution. We said it was a binomial distribution. Number of trials, he's going to go 10 days in a row. The probability of getting a red light was 55% of the time. Okay, so if I hit this zoom fit, we get this here. This is what my histogram should look like. So the probability of getting 0 was just about 0. So that means 0 days out of those 12 getting a red light. It's very, very slim. Getting 1 red light would happen 0.004% of the time. Getting 2 red lights, getting a little bit more likely to hit 2 red lights, 0.02, so 2% of the time. 3 red lights would happen 7% of the time. 4 red lights, 4 out of the 10, happen almost 16% of the time. 5 red lights, about 23% of the time. The most likely is to get 6 red lights out of the 10. That would happen about 24% of the time. And then the percentages start to go down to get 7 out of the 10 red lights, about 17% of the time. 8 red lights, about 8% of the time. 9 red lights, 2% of the time. And 10 red lights, 10 out of the 10. Very unlikely if you get 10 out of the 10 reds, but it would happen 0.003 times. Okay, so less than 1% of the time. So if you know you come home and you get all red lights, not good. Or I'm sorry, you get, if 10 days in a row, if you get red lights, you know you're not doing so well. Okay, so that is the end of the recording.